11.1, we are starting sequences, and we're going to talk about arithmetic sequences and geometric sequences, okay? And right now we're just going to do the first page of Notes 11.1, and then you'll do a little check for understanding, and then we'll come back and do the back page. So let's take a look at this first page. It says arithmetic sequences. The arithmetic sequences are the difference, and you should be writing this on your notes as well, the difference between consecutive terms is the same. Now when I say difference, it's like I could either add 7 each time, subtract 4 each time. Those are kind of your options, right? We're going to either add or subtract the same thing for every term, and I'll show you kind of what that looks like. So for this one, I go from 4, so when it says A1, it's saying the first term. A2 is the second term, and so on. So if I go from 4 to 9, what am I doing? How do I get from 4 to 9? I add 5. Now, if this is an arithmetic sequence, that means I should be adding 5 every time, but let's check. If I go from 9 to 14, am I adding 5? Yep. If I go from 14 to 19, am I adding 5? I am. Perfect. So this is an arithmetic sequence because I have the same difference between each sequence. If I go backwards, I'm subtracting 5. If I'm going forwards, I'm adding 5. The formula that we are going to use for this is a to the nth term. I'm going to use my highlighter here. N is for the nth term, okay? And that just means it could be the first, second, third, 70th. It could be whatever number term it is. And when I say whatever number term, is even though it goes 4, 9, 14, the third term is what I would be talking about. I wouldn't say 14, I would say the third term. That's what I mean by nth term. Okay, then it goes first term. Okay, so if it says A1, that means it's the first term, the first one in the sequence. It's the one that starts our line. And then D is for common difference. And remember, your common difference is what is happening between each of them. So like this time, the common difference is positive 5. And then N, like we kind of talked about here, N is the term number. Okay, so is it the 7th term? Is it the first term? Is it the 12th term? And it'll ask you specifically, it'll say something like, what would be the 8th term in the sequence? And that's what you would plug in, is the number 8. And we'll take a look at an example like that in just a second, but let's go take a look at geometric sequences. So for geometric sequences, it's a little bit different. We're not worried about the difference between each pair. We're worried about the ratio between each pair. And so for this one, same kind of thing, you know, we're going and we have a list here. We start with 2, and then we go to 6, and then we go to 18, and then we go to 54. But take a look. To go from 2 to 6, I could add 4, but if I add 4 to 6, am I going to get 18? I'm not. So what has to be happening here is, since I'm getting bigger, is I'm multiplying, right? So to go from 2 to 6, what could I have multiplied by? 3 times 3. Now if I do 6 times 3, will I get 18? Yep. If I go from 18 to 54, did I multiply by 3? Yep. So the ratio is the same each time. I'm multiplying by 3, but I can't add and subtract the same number. I'm not going to get it. Then we use the formula if it's a geometric sequence, if it's a sequence where the ratio is the same, not the difference. We use a formula that is kind of similar. So you still have the nth term, right? That's what we would try to figure out, is the nth term, okay? And that just means what number it is. So like third term, that would be the nth term, okay? The first term, just like we had before, just the one that starts the sequence out. So like this time, 2 is the first term, right? And the last one, 4 was the first term, but this time it's 2, okay? and then the common ratio. So that's what's different about this one, right? Instead of the difference, we're looking for the common ratio, and the common ratio would be 3. We're multiplying by 3 each time. Okay? And then again, n is still the term number. It's still what we're going to ask for, so it might say something like, could you tell me what the third term is? And so I would put, for n, 3. Okay? Notice, look at these two things here. They're very, very similar, but what's happening is some differences that we can see here is that for this one, let's use purple, we're multiplying. But on this one, we're adding, right? This one, we're going to the power of. On this one, we're multiplying. Okay? Just make sure that you know the difference between these formulas. Let's take a look at some examples and see how we would work this. So, for example 1, the first 4 terms in arithmetic sequence are shown below. So it tells us already, it tells us exactly what kind of sequence it is. This one is an arithmetic sequence. If that's true, then we are going to be using this first one right here, okay? 1, 10, 19, and 28. Based on this information, write an equation that can be used to find the nth term in the sequence, a n, okay? Well, like we said, it already told us it was an arithmetic sequence, so we know we're going to use the formula a to the nth term is equal to a to the first term, okay, plus the common difference multiplied by n minus 1. Okay? So first things first, let's see what the common difference is. I mean, if you want to put down what A1 is, you can, because you already know that one. But let's look at what the common difference is. So how can I go from 1 to 10, from 10 to 19, 19 to 28? Can you tell what that might be? I'm adding 9 each time, right? 1 plus 9 is 10. 10 plus 9 is 19. 19 plus 9 is 28. So my common difference is 9. Now that I know that, I can start filling everything in. I know my common difference. I know my first term. Okay? And then the other thing that we're going to find out is the n term. But let's fill out what we have so far. So I know that a to the nth, or a nth term is a1. Well, that was 1. Plus the common difference, which we said was 9. And parentheses n minus 1. We don't know what n is yet. You could probably see it below it there, but it hasn't asked us yet. But you need to simplify. I don't want to leave my equation just like this. I want to simplify it. Remember, if you see a number in front of a set of parentheses, we're going to distribute it so we can simplify. I know that n times 9 would be 9n. 9 times negative 1 would be negative 9. So I have 1 plus 9n minus 9. Do you see anything that can be combined there? Negative 9 and 1. What would negative 9 and 1 be together? Negative 8. So the equation is really 9n minus 8, because we had to simplify. Okay, so that is your equation. Now you can plug in what n would be, the term number that it's asking for. And the term number that's asking for, it says, what would be the 11th term? So that means we're going to be plugging in 11. So we would say, well, a, the nth term for 9 times 11 minus 8. Well, we know that 9 times 11 is 99. Minus 8 would be 91. So the 11th term, A11, would be 91. And then you're done. You solved them. Okay? And we'll kind of get the hang of it. We'll keep practicing. Okay, let's look at example 2. This time it doesn't write it out for us, but it does tell us, maybe, that A1 is 2. Okay, so the first term is 2. A2 is negative 4. All right. And A3 is 8. Okay, so the first, second, and third terms are 2, negative 4, and 8. Write an equation that can be used to find the nth term in the sequence. Well, first you have to figure out if it's arithmetic or if it's geometric. The last one told us that it was arithmetic, but let's double check. To go from 2 to negative 4, I could subtract 6. But if I go from negative 4 to 8, can I subtract 6? I can't, right? That doesn't make any sense. So it's not an arithmetic equation. Let's check to see. If I go from 2 to negative 4, I could have multiplied by negative 2, right? 2 times negative 2 is negative 4. If I multiply by negative 2 here, what is negative 4 times negative 2? Positive 8, right? Because a negative times a negative is a positive. So this has to be a geometric sequence. And if this is a geometric sequence, then we will follow this formula right here. So I'm going to go ahead and write it down. I'm going to say a to the nth term equals a, the first term. My a got a little wonky there. Times the common ratio to the power of n minus 1. And you already know some of these answers, right? You know, just like we did on that last one, we're solving for a, the nth term, and our first sequence, our first term was 2. Okay, so 2, and then times the common ratio, which you found out, was negative 2. So, okay, now I'm going to say 2 times negative 2 to the power of, and we don't know n yet, minus 1. Okay. Now on this one, can we simplify? That's what we're going to look for, right? Thing that we can combine. No, there's not anything that we can combine. We can't distribute when it's to the power of. You can only distribute when it's multiplied, right? So we leave it just like that. Now we can plug in our nth term. So we would say that we want the 12th term, okay? And so you would say 2 times negative 2 to the power of 12, because that's what it's asking for, minus 1. Now, you might be thinking to yourself, Ms. Bailey, I can simplify 12 minus 1, and you can, absolutely, now that you have the nth term. So you have 2 times negative 2 to the power of 11, okay? If you do not know how to solve this, what can you use? Who is your best friend that you can always count on? You can count on, oh, I don't want myself here. I want let me see. I want Desmos. And you can put Desmos in exactly how you saw it there. And guess what? It tells you right there, negative 4,096, which is kind of a crazy number, but it is the 12th term. And that kind of makes sense, right? If I keep multiplying negative 2 times negative 2 times negative 2 times negative 2, I'm going to get bigger and bigger and bigger. So the 12th term was negative 4,096. All right, you are going to check your understanding with a Google form, and then I will see you again for the back page of these notes.